All right, so I'm going to move into, rather than just finding area under a standard normal distribution curve, now I'm going to find an area under a basic normal distribution curve. Let me show you what I mean and what the difference is. Obviously, both have this symmetric bell-shaped curve, correct? And we know that the standard normal distribution curve has a mean of 0 and a standard deviation of 1 always. And the values along the horizontal scale are always z-scores. The center is 0. I mean, this is supposed to be symmetric. So now I'm on another curve, which is also symmetric and bell-shaped. ND is going to be normally distributed. And so ND is just a normal distribution situation. SND is standard normal distribution. But when I'm not standard, the mean and the standard deviation can vary dependent on the situation. And the values along the horizontal scale, don't represent z-scores anymore. They represent whatever situation I am dealing with. So, and then of course the center is the mean. So what I mean by that, so let's look here. This is a typical statistics type of situation. Find the area of the shaded region. Now this is straight in your face. Find this. This is what it looks like. It's drawn for you, obviously a simplified version of stuff, but I'll do other examples anyway after. But it tells you that it's normally distributed, right? IQ scores. And they're normally distributed with a mean of 100 and a standard deviation of 15. So that's for all of these. So this is an ND curve, not an SND curve. And rather than these values along the horizontal scale being z-scores, they are now IQ scores. Okay, IQ scores for adults. So this represents an IQ score of 118. This represents an IQ score of 91. This represents an IQ score of 79, 133. And you can see the difference between the values along the horizontal, on this curve rather than, on a standard normal distribution curve. So now, you have to know which curve you're on. The thing about this situation though, so first, find the area of the shaded region. So there's a couple different ways that I can ask that. I could give you the picture and say, find this area. Or I can say find the percentage of IQ scores that are less, right, to the left of 118. Or I can say find the probability that I randomly choose an IQ score that is less to the left of 118. Because remember that area is also probability or also percentage. So, all three are fair game. At the end of the day, when you're looking for an area or a percentage or a probability, we are using normal CDF. Normal CDF. Now, I have a TI-84 here that I'm using for this situation. And normal CDF we know how to find, right? Because we go second vars. So we've done that before, normal CDF, right? Number 2. And mine directly asks for lower bound, upper bound, and look, mean and standard deviation. Now, not everybody has the fancy, schmancy calculator. So if you don't have that, the order in which you input your values would be lower, right? Upper, and now mean and standard deviation. Okay, so now you're adding these two at the end. So if I want to do this particular situation, normal CDF for this one, the lower bound is negative infinity, right? And we said that when we have a lower bound of negative infinity, we don't have negative infinity to represent that, so we just use a big, large negative number, comma. The upper bound, what is the rightmost value that separates this area from the rest? 118. But now I'm not done, comma. What is the mean? The mean is 100. That is my mu, right? Mean is 100, and the standard deviation, which is sigma, is 15. 100, comma, 15. So this is the order in which you input it if you don't have this special calculator that directly asks for it, right? My lower bound is, so it's already in there, a large negative number. My upper bound was 118. My mean was 100. And my standard deviation was 15, right? When I paste this, it looks the same as, you guys that have the 83s anyway. That's the same order, lower, upper, mean, and standard deviation. Enter, and now I have my probability, my percentage, 0.885, rounding to 3 digits to the right, 0.8849. So we'll go 0.8849 for this one. So approximately 0.8849. Now, if I ask for probability or percentage, you can convert that to a percent. Remember that area is the same as percent or probability. Not bad, right? But, you know, if I don't have this and I'm on a standard normal distribution curve, you have to know, you know, in those situations that the mean is 0 and the standard deviation is 1. Okay, otherwise you have to be told what they are. Here I want the area to the right of this IQ score. So again, area or probability, normal CDF. My left or lower bound is now 91. My upper bound is a big positive number. My mean is 100 and my standard deviation is 15, because remember this goes to positive infinity. If I don't have positive infinity, then I'm just going to use a very large positive number. So second vars, normal CDF, which is number 2. Enter. My lower bound was, what the heck was it, 91. My upper bound is a large positive number, 1 with a bunch of zeros. My mean is 100 and the standard deviation is 15. I have to make sure that's there, right? Enter again, 0.7257. So approximately 0.7257 is my area. 72.57% would be my percentage greater than 91. My probability of somebody greater than 91 would be 72.57%. Right? All those are fair kinds of questions. Here, again, I want area in between two IQ scores. That's easy. My lower bound is directly given. My upper bound is directly given. My mean is 100 for this case. My standard deviation is 15. So, you know, when you're given, you know, area between two values, that's easy. You're given everything. Lower bound was 79. Upper bound was 133. Mean was 100. Standard deviation was 15. 0.9053. So approximately 0.9053, 0.9053. So what can I say? The area between these two values is 0.9053, or the percentage between, a percentage of IQ scores between these two IQ scores is 90.53%, or the probability that I have an IQ score between these two is 90.53%. All of those types of questions are fair game for this type of scenario.